How do we train the model? We define some steps. Okay, look into this data, identify the marks by college, identify the marks by gender, identify the marks by region, identify the marks by background, so on and so forth. And then, make some assumptions. AI makes some assumptions. AI derives some conclusions. So AI will say, okay, well, out of these 1 lakh students for the last 50 years, I can clearly see that, 90% of people who are getting very good marks are coming from, let's say, English honors stream, and not the normal English BA English scheme. So or maybe 98% of people are coming from that scheme. So the model has already has been generated. And I'm explaining this at a very simple level. So, you did a sequence of steps, you pulled in some data, and you've already generated a model. So what would happen is next time when you give it some data to say, well, here are 10 colleges, 500 students. Give me some predictive analytics around how would be the performance of students across these colleges. So you could safely make a bet that, well, there is a 90% probability. And when we think about AI, we think in terms of confidence level. So I'll say, well, I'm 90% confident that someone from English honors probably would be faring much better than someone who is just doing the ordinary BA course. So we created a model and we started deriving some conclusions out of that model. All I'm saying is that once we have created the model, we don't have to do that algorithm, data input, all of those steps again and again. All we do is we have trained the model, we have got the sequential steps, we have put in the data, the model is trained, there has been some supervised learning that has happened. The model think it's fit for purpose, it's good to go. And then all we have to do is just give it some data and boom, it will give you the results. So we don't have to repeat the same story all over again. Did that make sense, Preeti?
Sir, yes, sir. Thank you so very much.
Okay. Any other question? All right, let's move forward then, if there are no questions. So let me just kind of take a slightly more theoretical perspective on this. So what is intelligence? Just trying to explain this concept in a different way now. So what is intelligence? So intelligence has all of these different components. So, being able to learn. Being able to learn a new language like English or French. Planning, so planning for your next trip, to your favorite market, mall. Problem solving, so as an example, solving problems of mathematics. And then recognizing speech and faces. So obviously you would know, let me just hide this, sorry. So you would know that, if you've met a friend 10 years back, even whilst you will look at his or her photograph, you will be able to recognize her. So these are some of the fundamental aspects of intelligence. And all we're trying to do is, okay, these are all aspects of human intelligence. How do we replicate that using computers? And that is what would actually strengthen our conceptual understanding of how AI and ML works. So what is natural intelligence? Going back to that previous slide one more time. So as we all know, we have varying kinds and degrees of intelligence, and indeed in some animals as well. It's just not in human beings, but there are animals like dolphin, and there are animals like dogs, which are very intelligent, which can recognize, which probably have much more powerful sensory capabilities than even we have. And this is natural intelligence, because this is naturally occurring ability of our brain. And again, as I'm saying that, some animals like dolphin also have this kind of intelligence, and they can learn these tricks very quickly. So, so artificial and intelligence. So this was natural intelligence. So what is artificial intelligence? So we've talked about this phrase or this acronym AI, and it got popular on Modi ji's visit, our Honorable Prime Minister's US visit, in a different way. So, artificial intelligence, but also, and also America and India. So there was this famous sort of acronym that happened. But at the end of the day, for this session, it's AI means artificial and intelligence. So, artificial is something that's not natural. It's man-made or created by man. So there are natural flowers in the garden, and they are very different from the artificial plastic flowers that we use in the vase, right? Similarly, artificial intelligence is also the ability and intelligence which is created by human beings in machines, and is not found in machines naturally. Very important concept to remember. Machine on its own will not be able to do anything unless it is provided instructions by human beings. So give a machine terabytes of data, but if you don't give it any instructions, it would not give you any results. It would not give you any output or anything intelligent. And that's why, if you go back to that slide where I was talking about data and then algorithm. What is algorithm? Algorithm is basically that sequence of steps that actually will help machine process information and give you the results. So something very important to understand: machines are zero or worthless if you don't give it instructions. And the whole engineering or the science or the whole value of machine learning and AI is being able to give those instructions in a coherent manner. So forget about coding, forget about whether you know Python or not. The fundamental concept that you need to master for machine learning and AI is programmatic thinking, or being able to give those instructions in a clear, logical, sequential, step-by-step manner. Okay? And something very important to remember here, machine on its own will not do anything. It actually works the basis of instructions provided by human beings. So artificial intelligence is a way of making computer, robot, or software think in a similar manner, in the manner an intelligent human being will think. So artificial intelligence is adding intelligence to the computer. Again, computer on its own is just a piece of hardware. Unless you give it instructions, unless you give it data, it doesn't amount to anything. So artificial intelligence is accomplished by studying how human brain thinks, how human learns, how humans decide and work while they try and solve problem, and then using the results of this study as a basis of developing intelligent softwares and systems which can help computers think in a similar manner. Something very important to remember: how are these multi-billion models and algorithms made? At the end of the day, they are just mimicking how a human brain thinks, how human beings learn, how human beings decide and work, and how human beings solve a problem. At the end of the day, they are just replicating that, and of course, replicating that at scale, replicating that faster. So I might take one entire day to pull those calculations or make a beautiful Lego truck, but computers or a robot will do that in a matter of minutes, because it has already learned by observing or by ingressing the data that has been fed to it, wherein it observed what hundreds of human beings actually did when they were working naturally on it. So simple concept, but very important to remember. AI, how is AI accomplished? How does AI happen? It's a simpler replication of how we as human beings think, learn, work, try and solve problems. That's being replicated in algorithms and models. And for that, imagine, how expensive those algorithms and models are. Okay. So intelligence is the ability to learn new things. We all use our intelligence to learn subjects, understand them, solve different types of questions. Varying kind of intelligence occurs in people. As students, our teachers support and teach us, helping us learn new things and help us become more intelligent. And I'll come to you in a minute why I'm emphasizing this. Machines don't learn on their own. Of course, there is something called unsupervised learning, but at a fundamental level, most starting level algorithms or most starting level models learn when you teach them. So there is something called machine learning, and there is something called machine teaching. And machine teaching is a very important skill and a very valuable skill to have. So how does this learning work? And I've actually now tried to go back to some examples from nature. to actually help you understand this concept. So what is it we can learn from the animal world? So we've got 3 animals who are probably the smartest in the animal kingdom. So we've got dogs, we've got a chimpanzee or a gorilla, and then we've got dolphin. And they are intelligent. They're very intelligent. They can replicate, as you see here, some of the things that human beings do. So for example, monkeys and gorillas can be taught to eat in a plate or a spoon. Dolphins can be taught to paint. Dogs can actually, jump through these hoops of fire. So all of these things require intelligence, but at the same time, all of these things require practice. A chimpanzee or a gorilla or a dolphin or a dog would not do that in first attempt. They have to be repetitively taught this. And that's the concept we need to understand how machines learn. Right? And it's very fundamental. I mean, I didn't learn English or algebra or anything, any subject in a day, and so I was taught, and it was repetitive. It was repetitive. And I remember from my old school days, we used to give this famous analogy: when you're drawing water from the well, there's a dent on the wall of the well. That doesn't happen in a day. That's years and years of rope and its friction against that wall that creates that dent or a hole. So likewise, human beings and animals don't learn in a second, and machines also don't learn in a second. However, that being said, why are machines so powerful and why they can do that in a matter of minutes? What has happened is they have been repetitively fed the data, the algorithms, and the results, and they have humongous processing power. So all the processing that I would do in a matter of 5 days or 6 days, machines can do that in a matter of few seconds because of their processing power. So the amount of data that's being fed into a machine and a human being is same. Human beings, because we are using our natural abilities of natural processing, would take maybe 5 days, but a machine can actually do that in 5 seconds, or maybe maybe with the advent of quantum computing, maybe in a 1 lakh of a second or so on and so forth. It's that fast. So that's the fundamental thing we need to understand, that it's actually that learning actually comes from multiple repetitions and multiple data streams that are being processed at a humongous power. So just going back to this animal world example, so animals are trained to carry out various tasks using their natural abilities. Many times animals are trained to do activities that humans do, and in that training process, they become more intelligent and start taking advantage of natural abilities of perception. As an example, dogs become more intelligent after training, and then they can use the cops with their sensory capabilities, the power of smell. So it's important to understand that training can help intelligence. Training can help improve intelligence and in human beings as well as animals, and can help them do new activities. So what is happening here is, in both animals and human beings, repeated practice helps them become more and more intelligent. Likewise, computers can be trained to become more intelligent and do new activities by repetition. So by repetitively pulling in information, data, by putting in models, algorithms, computers also start becoming intelligent. They also start doing new activities like maybe predicting a weather or maybe doing some advanced calculations, so on and so forth. And very important to remember, much like animals, computers also get better and improve with repeated practice and with more data and information. So at the end of the day, when you're putting in more data, more information, more algorithms, you're giving computers more practice. Except for the fact that I would take 5 days to accomplish all of those practices, computers would do that in a matter of seconds. So the time scale has shortened, but the amount of work or amount of processing computers are doing is actually just about the same. And that's where computers have become so powerful. When we talk about ChatGPT, essentially what ChatGPT is doing is, think about the ChatGPT universe as a massive library which has all the books in the world. So let's say that there's a long 10-kilometer library, and we had that library in past, apparently in Nalanda. So there's a 10-kilometer library, with millions of books. So if I were a human being, it would take me years to master all of that data, and then being able to pick out, okay, this is a book on psychology. On page number 52, this is the concept that has been explained. ChatGPT, because it has advanced processing power, think about ChatGPT as that beast that actually has read all of that library books in a few seconds and now is ready to answer any question you have. So what has changed? The process remained the same. The data was the same. The algorithm or the sequence of steps was the same, but what changed was the processing power, which is infinitely more powerful than the human beings. And that's why computers have become more intelligent. So what we can learn from human being, from animal world, so animals can be trained to do repetitive tasks like finding food and doing different things. Similarly, computers and machines can be similarly trained to execute goals and some of the instructions that you will give to them. And how does that work? So you decide what you want AI to do, give it a goal. So for example, weather prediction. And then you give it some raw data or inputs. Okay, last 500 years of data, rainfall data, last 500 years of temperature data. Give it some instructions to provide, do the goal. So that is where your algorithms come into play. So, well, last 500 years of rainfall data, make sure that you put months of June to September as monsoon months. So identify the ups and downs of rainfall during that month. Identify the months where you had winter rainfall. So you will give it some instructions to analyze that data. And then using its higher processing power, using its very strong processing capabilities, AI will help computer do some actions, or it may be giving some predictions. It might be telling you, okay, next year would you have a good monsoon or a bad monsoon, so on and so forth. And that's why it's infinitely very powerful. I want to pause here. There's a lot to talk about and think about here, but I want to pause here and see if anyone has a question.
Any participant?
Okay, and let me just make sure
yes, Meera ma'am.
I check the notes as well, or the comments.
Actually, this is another concern, and also I just need to add my knowledge with regarding to that. Is that we know that the human beings are not poor as they have the intelligible intelligence to identify a thing, and they have the capacity to look after all the things, if I am not wrong. We have the senses. That means that we have the sixth sense also. Why can't we invoke the sixth sense in our educational system and make or equip the coming generation to get into the knowledge of or get into the that much of why can't we equip these upcoming generation to face all these things where the machines have been doing? That is the one question or one concern, because we all know about the universities, because the Nalanda University, which is the largest and ancient university in the world, its library, sir has also told about its library, and it has taken days or months I think so. It has been, once it has been burned, it takes months to get it into destroyed. So that kind of repository of knowledge which we had, and why can't, as we all know that about Swami Vivekananda also, we might have heard about, within a second he covered all the books in big books, and likewise we have many great personalities in the Indian culture also. Can you say about how can we compare all such things? And this is another concern of me. Thank you so much.
Okay, there's lots to unpack here in your question. That's a good question. So lots to think about and unpack and reflect for all of us. So you spoke about sixth sense. So essentially, what is sixth sense? So when we say, okay, well, I have a sixth sense that this student, and I'm not being judgmental or not being biased, but I have a sixth sense that, I've spoken to the student for 5 minutes, and I have a sixth sense that this student is going to be my topper next year. He's brilliant. Now, where does that sixth sense come from? Yeah, let's just try and think about it. So that sixth sense actually comes from experience. So you've actually met and spoken thousands of students. You have spent hours talking to students, and unconsciously imagine and think about this in a different way. So practice, yes, absolutely. So think about this in a slightly different way. Unconsciously, your mind is still inputting that information. You might not realize this, but your senses, your eyes, your ears, they are all feeding lots of information to your brain. So, you see all the faces, you see 50 faces, on a daily basis, and year after year. So there is lots and lots of data that's already being fed into that brain, and unconsciously you start developing your own models. This is another good example of your model that you develop over a period of years. So that's your sixth sense model. I've seen a lot of professors, and I personally know a couple of my professors. They speak to you for 2 minutes, in the beginning of the year, and they would know that, is this my student? Is this going to be my rock star, or is this a student on which I'll have to work very hard? How did they get that sixth sense? Because they've spent 40 years. So multiply 40 by number of students per day into 365 years into 40, and multiply that by 60 to give you actually the amount of time they've spent with those students in minutes. So you see that there's a big data. So that data has helped develop their sixth sense. Now, what's different with machines, as I was explaining, is this time period contracts. Just because we are feeding it lots of data, we are feeding it models. So essentially, there was a model that would be developed by Chakraborty sir, and I'm talking about some of my favorite teachers here. There was a model of analyzing or thinking about students that was developed by Shinde sir. There was a model that was developed by Gupta sir. Combine all of these models, and you have about hundreds of years of experience distilled in a model. And you are then giving that model to AI. Think about how powerful it will become. The one difference is that it took 40 years for my favorite teacher, Chakraborty sir, to arrive at that sixth sense. For computers, just because they are able to process all of that data in 1/1,000,000th of a second, it will probably take 5 minutes. So that's a little bit of a color on sixth sense. Now, to answer your second question, how do we imbibe some of these capabilities? And you brought in Nalanda, so I'm assuming that you're thinking about people being able to read, people being able to write, people being able to think about things intelligently, critical thinking, and all of that. So how do we imbibe those capabilities, and how do we make our students intelligent so that they can face the AI world? Well, I would say that probably the context has changed. So in those days when we had that university, paper was probably just invented, so everything had to be documented. There were no data farms, there was no data servers. So the need of the hour at that point in time was people being able to document, people being able to write. And of course, when you write, you become better in articulation, you become better with your language, and so on and so forth. The need of the hour today is slightly different. The context has changed. Obviously, we are way beyond the paper and pen age, and now we are in the digital age. So we've got machines who are at your doorstep. Like it or not, you've got machines who can do all that stuff for you. All that admin stuff for you. So what is it you could do? you probably could use your what I called higher order intelligence capabilities or higher order thinking capabilities to solve problems using these machines. So think about and thankfully in our country there are multitudes of problems to solve, of course, and not just in our country but in larger world as well. And there are some glamorous problems. People build companies like Zomato, Ubers and Googles of the world, but there are not so glamorous problems as well. So think about agriculture, think about food processing, think about crores and tons of food that we waste every year. So that's a problem that we can solve. But the good news is that you don't have to be an expert in food technology. You don't have to read a book on food technology or do a course on food technology. You don't even have to be an expert on machine learning. All you need is an ability to connect the dots. All you need is a bit of a critical thinking faculty. All you need is a bit of design thinking ability, and boom, you might be able to solve that problem. So I would say, to answer your question, what we probably need in our students is probably slightly different than what was needed 100 years back, or of course, 5,000 years back or 10,000 years back, because the context has changed. The world is a different place now, and we don't have a choice but to just adjust with the new digital paradigm. Does that answer your question? And this can be more of an open-ended discussion that we can take up at the end of the call as well. But does that answer your question to some extent?
Thank you, sir. Thank you. Thank you so much. Any other query?
Okay.
Yes,
there you go. There's a question.
Yes, sir. Thank you so much for such an informative session. This is not a query, but when you were showing the slide related to human intelligence and artificial intelligence, I was just wondering, human intelligence also includes interpersonal relationship related skills like emotional intelligence. Also, yep. We do talk about, but that was missing. Just an observation which I
yes,
just to share.
Yes. So very interesting question and very fascinating topic. Can emotions be replicated in machines? And it's a debate, and to be honest, we will not be able to settle that debate in today's call, and we should not even try that, because then we'll go off track. But I'll give you a very simple way to understand and maybe process this. So at the end of the day, what are emotions? Emotions are our brain neurons making some connections. So if I think about my family, there is a particular emotion. If I'm chilling out with my friends, there's a particular emotion. If I do a wonderful project, there's a particular emotion. So what are these emotions? At the end of the day, at a fundamental level, at a fundamental molecular level, or at a very fundamental level, these emotions are the connections or the connectivity between neurons. So I would not be surprised, with quantum computing, with all the humongous processing power that's today possible, at some point in time, computers would also start to have those emotions. Now, the way I would like to think is that they would still be a processed emotion. They would not be they would still not be a natural emotion. So just go back to that example that I was giving. There's still a difference between a natural flower and the flower in a vase, right? The artificial flower in a vase. So they may look different, or they may look similar, but they will still be different. So human beings have emotions that are those neurons and connections between neurons and so on and so forth, that probably at some point in time can be replicated in machines. Already sensory capabilities are being replicated. So think about touch. Now you have touch phones on your smartphones. You have touch on your smartphones. Was that possible 20 years back? No. So we don't know what the art of possible is, and there are a lot of known unknowns, and there are a lot of unknown unknowns. So this is a realm of unknown. How do you bring? Can you actually make machines emotional? I would like to believe we can. Theoretically we can, but this is still an ongoing debate.
Thank you, sir.
But I would say that a machine which has emotions probably might not be the best thing to happen to the world, because think of a machine which gets angry, and think about that machine which has that processing power, that might to to do anything. You think about these machines which start having emotions of anger. I think the world would probably be a very dangerous place. Already we are facing a lot of challenges in the world because of human beings who are angry and and are dictators and so on and so forth. And think about machines who are angry and who have emotions and who start behaving like dictators. I don't think world would be a very safe place with those processing power capabilities. Anyways, moving forward, so let me just share one more time. Okay, so present, and then I present my screen. Just give me a minute. Okay, just give me a thumbs up or a shout out when you can see my screen, please. Can everyone see my screen? Yes. Yes or no, please. Can everyone see my screen?
We can.
Okay, perfect. Thank you. So just to summarize this concept, this is a simple example of how fundamentally machine learning works. So, we've got, and this is again, just replicating the human behavior. So you've got 4 or 5 different types of flowers. You tag them. So you will tag rose as rose. You will tag sunflower as sunflower. You will tag tulip as tulip. And then what is happening is machine, when you're tagging them, machine is observing you. AI is actually observing you. So next time when you present a rose in front of it, it will be able to say, okay, this flower is rose. So simple example to understand how machine learning works. It's a repetitive iteration. It's a repetitive iterative process. And, part of that is called supervised learning. And that's how you really develop your models and algorithms, because you repeat with all of this humongous amount of data, you repeat all of these steps a million times. And the more you repeat, the more data you have, the more accurate you will get, right? Because what you will start doing is, instead of a red rose, you will give it yellow rose, or you will give it a pink rose, but the machine would still be able to understand, just because rose is slightly bigger than tulip, it's still a rose. So machine will be able to understand, provided you give it lots and lots of data. Okay, ethics, something for us to really reflect on today. And this is, keep in mind, there are no right or wrong answers here. This is not meant to be a prescriptive module with ethics. You should never be prescriptive. I don't know my ethical framework is correct or not, but I can give you some ideas and some difficulties and some challenges with ethics and AI. Of course, the biggest one, we are all aware, the elephant in the room, plagiarism. People just going up to ChatGPT, copying their essay or their write-up straight away from ChatGPT, and writing a glowing tribute on, let's say, Mahatma Gandhi, or writing a wonderful essay with beautiful language on cow. None of that is original, which is a 2-minute job, which actually would have taken a child years to master. So that's the biggest challenge. That's plagiarism. But beyond that, there are some other challenges, and there are some other difficulties, and there are some ethical dilemma as well that I want to talk about. And I'm if there are folks from psychology, or if there are folks from other pieces of humanity, want to know your perspective, because as I say, no one view is actually correct here. People will have different views and different ways of looking at it. So open to sort of other views, and let's make it a bit more interactive discussion, because all of you would enjoy talking about it. So ethical issues. So AI in education. So AI has variety of applications. So we know about personalized learning platforms to promote students' learning, automated assessment systems, facial recognition systems to generate insights about learner behaviors. So these are some of the educational applications. Now, where are the ethical dilemmas in this? So let's think about this. So despite the potential benefits, the ethical and societal drawbacks of these systems are not considered, at least especially in Indian context. They are still not understood and considered. The ethical challenges of AI in education must be identified and introduced to teachers, parents, and students. Very important. Some of these challenges and difficulties are probably coming from a slightly Western worldview, I would say. But and part of that, of course, is probably, again, some bias some bias that floats in all the literature that talks about all of this. And that's why I said, this might not be a complete view, and I'm open to different ideas that you guys might have. So success in AI would be the biggest event in history. Unfortunately, it might also be the last unless we learn how to avoid the risks. This was something that Stephen Fleming said. So we all are aware of wonders of AI, but we're also people are increasingly getting worried about the dangers of AI and dangers of these all-powerful machines. So AI has a variety of algorithmic applications and educations. We've talked about that: personalized learning systems, automated assessment systems, and so on and so forth. Let me just walk through this slide real quick. So here are some ethical drawbacks and challenges. So the biggest challenges of integrating these algorithms in educational contexts are: number one, perpetuating existing systemic bias and discrimination, perpetuating unfairness for students from mostly disadvantaged and marginalized groups, amplifying various forms of injustice and inequality, informed consent. So for example, if I am, and this is where, it's actually a bigger problem than just education. So when you are playing with your smartphone, when you're Googling, when you are actually Googling, okay, tell me something more about heart disease, or tell me something more about this disease, that disease. At the end of the day, there are cookies, there are those little tidbits of software that are learning from all of that, and they are probably being the big brother who is knowing all the information about you, all the intimate and confidential information about you, without even you being aware of that. And does anyone ask you? So does your Android phone ask you? All they do is accept all cookies, and you end up accepting cookies. But does anyone educate you on the consequences of sharing this information? Unfortunately not. And it's a worldwide problem. I'm not saying this is an India problem, but informed consent. So when you actually ask for any data or information from a person that would be used for that algorithm, are you taking his buy-in, number one? But more importantly, are you informing him about the pitfalls or about the implications of providing that information? So that's something that for all of us to think about and reflect on. Privacy, data integrity. Again, your mobile phone is probably your world, but people from all sorts of places are snooping on your world. So not very reassuring. So the ethical challenges and risks posed by AI systems actually run counter to marketing efforts that presents AI to public as if AI is very objective and a value neutral tool. So, you will hear this all the time. Well, computers don't have bias. Computers are never judgmental. Computers are very objective. No. If you go back to that conversation that we were having earlier in some of the slides, at the end of the day, the artificial intelligence is a sum function of what you feed into it, what are the steps you are telling it, and with that, some biases that are in your mind would also creep in. And when you think about the scale, humongous amounts of data that's being put in, those biases just get amplified and multiplied. I'll give you a very simple example, something that many of you would relate to. Now, we all know seat belts in cars. Yep. So there is a very fascinating article, and if you Google, and I would not name the company, it's not right for me to do that, but one of these big car companies were designing seat belts. They did the algorithm and they did some machine learning, and they carved out a beautiful design of a seat belt. But when there was testing happening, and when actually, some of those cars were rolled out, people figured out that many of those seat belts were not working or in a situation where the driver was a woman. And it's a very interesting case study. You Google it, you will get it. And I don't want to name the company. It would not be right on me to do that, but it's a very interesting case study. So what happened there? I mean, at the end of the day, there were about 100 engineers who were doing these humongous algorithms. Out of those 100 engineers, probably 99 were male, and probably didn't. They had their own biases. They thought about seat belts from the perspective of their body structure, and obviously, body structure of men and women can be different. So what happened? The output was that even with that amount of artificial intelligence, even would you like to believe that it's a gender agnostic tool, it turned out that those seat belts were not safe for women. So something to remember and something to sort of take away from this session. So in essence, algorithms reflect the values of their builders who hold positions of power. Whenever people create algorithms, they also create a set of data that represents society's historical and systemic biases, which ultimately transform into an algorithm bias. So again, going back to that conversation I was having earlier, I mean, at the end of the day, data is being put into AI by human beings. AI doesn't become intelligence by itself. It's the human beings which are making it intelligence. And we all know garbage in is garbage out. So if you put in a lot of data which already has biases, the algorithm would also have bias. So they created a set of data that reflected society's historical systemic biases, which ultimately transformed into algorithmic bias. Even though the bias is embedded into the algorithmic model with no explicit intention. Again, very strong emphasis. This was not intended. That was not intended, but subconsciously, at a subconscious level, without that person or without that group of people even not realizing it, that crept in. And that's where we see various biases in different AI-based platforms. So something to be very careful about, especially because as educators, as teachers, teachers build the nation, we say, right? And you cannot be seen as being biased or discriminatory, and you cannot be seeing developing products that are inherently biased and discriminatory. So something to think about, and the way to tackle this is, really human-centered design, but that's a separate concept altogether. That's another discussion for another day. But the way to sort of remove some of those biases or preempt some of these biases to actually use human-centered design. So, with that, just a quick sort of a summary. It's also important that ethical design started to be incorporated. So human centered design, and there is something called ethical design. So ethical design started to be incorporated in more and more AI-based systems. In addition to ethical design, decentralized design thinking design techniques like design thinking, human-centered design, and keeping all stakeholders in mind can also be helpful in creating a robust framework that would help in ethical AI design. So with that, I want to pause. Very interesting topic, and I'm sure a lot of people, especially from humanities side, would have perspectives. So open to perspectives, thoughts, even critique. As I said, what I'm suggesting might not be the best model, or might not be the best value statement. But open to ideas, suggestions, critique, feedback, what people think about, especially this ethics and AI topic.
Thank you, Kapil. You have very effectively and very elaborately explained the things, how it works and what are the implications for its work. And ultimately, you ended your lecture with the real issues, which we call ethical issues. And the two questions which you answered are excellently done in terms of the emotional aspect of it and how machine works and how these have been very heavily explained by you. I must congratulate you, and you have done a very good job.
Thank you, sir.
Any other participant?
Good evening, sir. Welcome.
Kapil, you have done very good job. Are you hearing me, Kapil?
Yes, I am, sir. Thank you.
Yeah, you've done a very good job. And two questions you answered were excellently explained, how machines work and how the algorithm works, how neurons works, that's a kind of thing. And that's for And the last question on emotional intelligence, it is still we are working on that. They are working on it. I think both the questions have very heavily answered. We must congratulate him, thank him. And if you like to have break, what is the Priyanka and Prachita? It is your take now.
Yes. First, I would like to thank our resource person. It was a very enriching as well as very energetic session. And there is so much of energy in your voice, which shows your love and passion for your subject. And definitely a smart society needs intelligent systems, which can only be achieved by applications of artificial intelligence and machine learning. Artificial intelligence is making contribution in everyone's life for betterment and wellness of society. So it is the need of the hour to adopt AI and machine learning. Thank you so much, Kapil sir, for sharing the knowledge and information with us. Thank you so much.
No problem. So what I will do, just because we're running out of time, and I had a couple of more topics to cover, and I could actually have done a demo as well. But what I will do is I will leave some of these links and videos with Sharma sir or maybe Priyanka ma'am, and you could circulate them around.
Sure, sir. So there is I just want to ask, there is a movie named Megan, which is on artificial intelligence.
Yep.
And that is related to that question of emotional learning and if you connect it with robotics or machine learning. So,
Yeah. Go ahead. Sorry.
So is that possible in real life?
Well, that's what I'm saying. I mean, theoretically, anything is possible because computers today, just because they have humongous processing power, they have humongous ability to ingest terabytes of data. And at the end of the day, with quantum computing, you would end up multiplying that processing power by millions and millions of terabytes per second. So theoretically, everything is possible. What you would have to do is, again, going back to what I was saying, you will have to create a model of how human beings develop that emotion. Now, obviously, that would happen with trial and error. So, if I'm not a brain expert, but, at the end of the day, how do we have emotions? It's there's some magic happens in the brain, and then certain hormone gets released, and, we feel happy about it, and so on and so forth. So that needs to be understood, number one. Of course, we don't understand the mysteries of brain just yet, but that, number one, that needs to be understood, and that needs to be replicated, at a neuron level. And then the signals, so, once neurons interact in a certain manner and all of that, there are some signals that come from our brain that makes us feel happy, sad, angry, so on and so forth. So those signals again need to be replicated, and then you have to replicate those same signals that could be understood or maybe deciphered or processed by a machine. So theoretically it's possible, but hopefully for the betterment of society at large, we are probably some years away from it.
Yes, sir.
Okay, well, if we have 5 minutes, I can give a quick demo if people are up for it. And of course, people who want to sign off or want to take a break can sign off. But if you are up for it, I can give a quick demo and then we can round it up.
Yes, sure, sir. Sure, sir. You can.
Okay, so let me see. Okay, let me just share my screen real quick. Okay, looks like I'm presenting. Okay, so this is a language text analytics, and how does this algorithm work? So, and of course, this is a pre-built algorithm. This is not something that I have built. This is pre-built algorithm by Microsoft. But I'm just demonstrating you the power and magic of algorithm. And so essentially what it is doing is you enter your text. So I've already entered the text. So, there's some, and this is very objective information. So Saturn is the 6th planet from the sun and second largest in solar system. It is a gas giant with average radius about 9 times that of Earth. Now, what I can do is, what is the key messaging out of it? The sentiment analysis. So we talked about emotions. The other side of the story is understanding the sentiment. So is it a positive statement? Is it a negative statement? Or is it a neutral statement? So analyze it. So if I click on analysis, so what AI would do here is, it has a model, it has an algorithm, and it says that it's a very neutral statement. If I would have said Saturn is the best planet in the planet solar system, it is even better than Europe, obviously it would have been a positive statement. Or if I would have said Saturn is shani, very dangerous, I'm scared, it would probably be a negative statement. So that sentiment, and understand please, sentiment is different from emotions, but the sentiment or the tone in this language is now being understood, and AI has the ability to do that. And that's where, the chat GPT, the large language models are also coming from. So, you give it some questions, and from the tone of your question, it will be able to decipher what would be the most appropriate answer. Now, that is not enough. If you try entity extraction, so it will also be able to extract some entities out of it. So it will say that, well, Saturn is an entity, planet is an entity, solar system is an entity. So, think about entities as nouns, some common nouns. So Saturn, planet, I don't know why sun was not there, but solar system, Jupiter, gas giant. And then, it's got that average radius 9 times. So it has identified all these entities, and the reason, the way it identifies entities is it thinks that there is an underlying dimension to it. So Saturn, as an example, is a planet. Planets are part of solar system. Again, solar system is part of space. Jupiter is again planet. So each of these words have a context or a relevance. And using that, it identifies the entity. Now, you can actually now search by that entity. So if you do the Bing search, so for example, this one, as soon as you click on this, it would actually pull up the Bing search. So Jupiter, it's a generic planet. So Jupiter is the 5th planet, and so on and so forth. So this is at a very simple level how large language models that constitute ChatGPT work. What they are doing is they are looking at your message. They are extracting the sentiment and what are the key parts of your question or your phrase. With that, they are using some entity extraction. So they are pulling some entities, and then when you search for those entities, they pull out the information. So this is how, at a very fundamental level, some of these algorithms actually work. Okay, and then what I can do is, and then of course, we've all talked about, we all know the Turing natural language generation model. So ChatGPT also is generative AI. So using all of these entity extraction, sentiments, phrases, it can then answer some of the questions. So for example, I will ask a question, how was universe created? So it has now started to generate an answer for that. So why this is important and interesting for you? If you are thinking that your students are using ChatGPT to plagiarize, if you understand how this works at a fundamental level, you will be able to very quickly read and understand whether this is something that has been generated by ChatGPT or whether this is something that a student has written on its own. A simple sort of rule of the thumb is something that's coming from ChatGPT would have a very neutral context. It would sound like just someone has taken a dictation. It would be bereft of any emotion. It would be very neutral in context. Whereas if someone has written an essay, there will be some emotion, there will be some passion that will come into it. So of course, this is a very big topic to think about and debate, but the message I'm trying to actually share with you and trying to explain and convey via this simple demo is to understand AI at a fundamental level, and you will be then able to, then work, you'll be able to work with the students or folks who are gaming the system by, copying stuff from ChatGPT. You'll be able to avoid getting into those situations. So understand this at a conceptual level, and hopefully this will help you, in your day jobs a lot more than what it does right now. Okay, with that, thank you for your time. Over to the organizing team. Any questions? Happy to answer.
Any participant?
All right. Well, what I'll do is I will leave my email and some links and some resources with the organizing team. Feel free to get in touch with them. And yeah, any questions or anything you need from me, let me know. There is another topic. I mean, the next steps, if you want to explore this topic further, the next step is how do you actually design a ML engine or a AI engine, and how actually you could do that without writing a code. But that's like a one-day workshop. So we probably would not be able to cover that in that session, but I can send some resources and I can send some additional reading materials that you could read and, get smart on this topic.
Thank you so much, sir. Thank you so much.
All right. Thank you, everyone. Have a good evening.
Good evening, sir.
Good evening, sir. Thank you. All right. So do we take, a break of 2 minutes, or do we start immediately? Okay. All right. Sir? Sir, is this all right? The participants, they're actually asking for a 2 minutes break, and actually we have 3 minutes to go till 5:30. So can we start, rejoin again at 5:30?
You should take the break for 5 to 7 minutes or even 10 minutes. They had heavy 2 sessions. First session was Moge and second session was MrKapilMurdia. There are 2 really heavy sessions. They should take a break. And I know Radhika and many people have asked for the break. You should give them break for 5 to 7 minutes minimum.
Sir, we will join. Abhi exactly it's 5:28. So we will join exactly at 5:35. Is that all right with you, sir? If that is okay with you, sir? 5:35. Right now it's 5:28.
5:35. Okay.
5:35. Exactly at 5:35 we will join. Thank you, sir, so much. I will introduce you then formally once again. Thank you, sir.
Good.
Thank you.
Good.
All right, participants, please join back exactly at 5:35. Please don't log out. Stay logged in.